Sydney, the largest city down under. It's like stepping into a different world. German physicist Professor Thorsten Trupke has lived here with his family for 8 years now.
The few hours in the week that you get into the water, these are maybe the few hours that you have for yourself with no one else around, no one talking to you, where you can just try to switch off or think about things that you would like to think about. That's probably the main thing.
His colleague, Dr. Robert Bardos, is Australian.
Life is never the same again once you have a child, and I could never imagine going back. So, yeah, I recommend people have more of them.
The two researchers developed a laser-based imaging procedure for photovoltaic cells and for quality control. Defective solar cells or silicon wafers can be detected and rejected during the manufacturing process.
One of the main benefits of our technology is obviously the speed at which you gain high-resolution insight into the material, and that's what I would like to demonstrate to you now. So this is a typical multicrystalline screen-printed solar cell. All I have to do is put the cell on the stage, close the door, and from here on things are just as easy as taking a conventional photograph. You press the button, type in the sample name, we do something arbitrary here, press acquire. At this stage the laser comes on, and you can see it's only on for 1 second, and after 1 second we get a high-resolution image of the solar cell. And that shows us specific types of defects, like, as you can see here, we can see specific crystallographic defects.
The Dream Team and their company, BT Imaging, achieved market introduction 3 years ago.
It was a very exciting time when we realized that our basic non-imaging PL technology could be transformed into an imaging technology which would be of greater industrial relevance. So the scientific side was fascinating for several years, but then we realized that we could take the jump from the scientific to an industrially relevant technology. I think it's fair to say we had many coffees and discussions together.
No beer?
I'll add some beer, yes, some beer as well.
I have more than he does.
The University of New South Wales, here at one of the world's leading centers for photovoltaics and photonics, is where the two pursue their research, and it is here that their success story began.
So this is basically where it all started. This is the first photoluminescence imaging system that we built. So you can see it's relatively basic. In this case, we actually used a couple of CDs in order to get the sample into the correct height.
The first couple of experiments were very sensational to see that the concept works. That had never been done before. That was very exciting times.
The future belongs to solar technology, not just in sunny Australia. They're both sure of that.
It's critical for Australia especially, but also for most countries in the world, that the risk associated with the enhanced greenhouse effect is reduced. And the way to do that is to save energy and to create energy from renewable sources.
The vision for the future would be that in the future we use more and more renewable energy, such as photovoltaics. And it is clear that if we don't, my children will not be able to do a beautiful swim through Coogee Bay. So I hope that the adoption of renewable energy sources will lead to a cleaner and more sustainable future for our children.